Okay, so short review lang. Para lang may reference tayo para sa lesson na to. And before we answer this. Okay. So last meeting, we have started discussing the introduction to mechanics, kinematics. Ayan. So we have discussed the quantities involving mechanics of physics. Ayan. So una nating diniscuss yung quantity ng position. Remember that position, in determining the position, we need the reference. Okay, so identify the position of a particle. So normally, pag horizontal yung motion natin, yung position natin is denoted by x. So x is the position. Okay, and then after that, we have differentiated what displacement and distance is. Ayan. What displacement and distance is, and what's the formula between the two, or how will we get the displacement and distance. So distance is a scalar quantity, which is the total path taken, while displacement is the shortest path or the direct path from the initial point going to the final point. Okay, so that is the displacement. And then, ang relation ng displacement and distance to average speed and average velocity. So we also have discussed that the average speed is equal to the total distance over the total time to cover that distance, while the average velocity is the total. It's a difference between the final position to the initial position over the total time to cover that displacement. Okay, so that's the difference between the average speed and average velocity. And since distance is a scalar quantity, yung speed natin is a scalar din, and then yung velocity is a vector. So therefore, displacement ang ginamit natin for the average velocity. So we have discussed also how to get speed and velocity involving distance and displacement. And next is we have discussed also yung instantaneous velocity. So we also discussed the difference between the two, instantaneous and the average velocity. Average speed and average velocity, if we want to deal with them, we need to attach the word average to say that it is average speed or average velocity, but the two do not have any relation at all between the two. Unlike for instantaneous velocity and instantaneous speed, ayan, instantaneous velocity is the derivative of is the limit of the average velocity as delta t approaches 0. So in short, we will get if we are given the equation of the position, we get the first derivative of that position to get the equation of the velocity. Ayan. And the relation of instantaneous velocity to instantaneous speed is that the instantaneous speed is actually the magnitude of the instantaneous velocity. So also the word instantaneous, we don't need to attach it to the word velocity and speed to mean instantaneous. So it's automatic. If we say speed or velocity, we actually mean instantaneous values. Pero if you want to say, if you are dealing with average, we need to attach the word average. But for instantaneous, no need to write and even write the instantaneous word before velocity and speed to mean instantaneous values. Ayan. Okay? So ngayon, we will be solving examples, okay, involving average velocity and instantaneous velocity. Ayan. So we have discussed that in the previous video. So mayroon tayong video doon sa conference natin. If you missed that, you can view it naman ulit. Okay. So let's have this example. Okay, a particle moves as the equation of the position x is equal to 4t squared plus t minus 16, where x is in meter and t is in seconds. Determine A. What is the position of the particle at t is equal to 2 seconds? And B. What is the average velocity from 2 seconds to 4 seconds? And C. What is the instantaneous velocity at t is equal to 2 seconds? Okay. Well, let's have the first one. Ayan. Because this is the equation of the position. Okay, so hinahanap natin ano yung position. So that means we're looking for x. Ayan. So what is the value of x? What is the value of x when t is equal to 2 seconds? Ayan. So ano bang gagawin natin? We will just substitute the time to our given equation because this is the equation of the position. To get the position at 2 is equal to 2 seconds, we need to substitute yung time natin doon sa equation natin. So therefore, x is equal to 4 times 2 squared plus 2 minus 16. So the answer is 4 times 2 squared plus 2 minus 16. It's 2. 2 meters. So the position, okay, the position of the particle after 2 seconds is at 2 meters. Okay, may question? Okay, wala. Okay, so let's continue. Letter B. What is the average velocity from 2 seconds to 4 seconds? Okay, yung average velocity natin, that's V average. Okay, so that's equal to delta x over delta t. Delta x over delta t. So that's equal to delta x over delta t. So that's equal to x final minus x initial over t final minus t initial. Ayan. Are we given x initial? No. X final? No. T initial? Yes. T initial, what's our T initial? T initial is 2 seconds. And T final is 4 seconds. So we're only dealing with 2 seconds and 4 seconds. Okay. Now, how will we find X initial and X final? Since we are given the T initial, so we can find the position of the particle initially. And since we are given the T final, 4 seconds, so we can also find the final position of the particle. Okay, so ganito yon. So if at T is equal to 2 seconds, X initial is equal to, we substitute the given time dito sa ating equation. So we'll have 4 times 2 squared plus 2 minus 16. So that's equal to, kamukha lang pala nung una, 2 meters. And then, at T final, which is 4 seconds, so that's X final, so that's equal to 4 times 4 squared plus 4 minus 16. So that's equal to 52 meters. Ayan. Okay, so therefore, V average is equal, we just substitute that dito. So that is 52 minus 2 over 4 minus 2. So that's equal to 25 meters per second. So the average velocity is 25 meters per second. Any question? Okay, so walang question. So let's proceed to letter C. Ayan. So ito na pinag-usapan natin, ang instantaneous velocity. So what is the instantaneous velocity at t is equal to 2 seconds? So based on the formula, ang instantaneous velocity natin is equal siya sa dx over dt. So that is the first derivative of the position. Okay, class. Marunong ba kayong mag-derivative? If I'll ask you, what is the derivative of our equation? Can anyone tell me what is the derivative of 4t squared plus t minus 16? Okay, Michael. Class, that's why I'm asking kasi you cannot do this if you don't know how to derive. So if you don't know it, at least I could teach you. If you will not tell me, I will not know. Kasi based sa subject natin, this is calculus-based physics. That's why we're doing this. If nahiya kayo, you can message me privately. Let's try to be as honest as we can. Because I will not know where to start if hindi ko naman alam kung saan pala yung yung shortcoming. So that at least I can fill the gap. Tama ba? Kasi if you won't tell me, I will assume that you know it. And okay, so at least someone told me his answer and he was actually correct. So at least alam naman pala ninyo. Okay, so the answer will be 8t plus 1. So therefore, the equation of the velocity is 8t plus 1. Okay, so that's the equation of the velocity. Okay, thank you for answering it. And then, since ang hinahanap natin is yung instantaneous velocity at 2 seconds, so therefore, i-apply lang natin yung 2 seconds. So therefore, velocity is 8 times 2 plus 1. Or the velocity is 17 meters per second. Okay, so that is the instantaneous velocity. My question? Wala. Okay, so let's try another one. Shortcut ko na lang yung problem. Ayan. Okay. So we are given again the equation of the position of the particle at x is equal to 2t squared minus 10t minus 2. Okay, we want to find what is the position of the particle at t is equal to 1.5 seconds. By the way, hindi ko na sinulat. X is in meter and t is in second. Okay? Okay, so letter A, what is the position of the particle at 1.5 seconds? And B, what is the average velocity from 1 second to 4 seconds? And C, what is the instantaneous velocity when time is equal to 3 seconds? Okay. Sa una is position ulit ang tinatanong. So that means isa-substitute lang natin. Okay? Substitute lang natin. When t is equal to 1.5 seconds, what's the value of x? So x is 2 times 1.5 squared minus 10 times 1.5 minus 2. So what's the value of x? Okay, it is negative 12.5 meters. Ayan. So the position of the particle is at negative 12.5 meters. Okay, letter B. Okay, what is the average velocity from 1 second to 4 seconds? Okay, can you try that one? Can you compute it for me? Can you solve it? So what is the average velocity from 1 second to 4 seconds? If you want a copy of that one, ito. So I'll give you like 4 minutes to solve. Ito example natin kanina in getting the instantaneous value, average. So ito na ngayon yung bago nating equation. Ayan. Okay. Find the average velocity. So I'll give you like 4 minutes to solve. Or try nyo na din yung instantaneous. Ipo-post ko muna yung recording natin. Your answers with you. So what do you think are the answers? Can somebody tell me what is the average? 0? 0. Michael, 0 yung letter B? Okay. I'm not sure. Siguro map. Okay. We'll see. Okay, let's try to solve it. Okay, so what is the V average? So that's equal to delta X over delta T. So that's X final minus X initial over T final minus T initial. Nangyayari sa mga pen ko. Ano kung sila? Ayan, so what's okay, T initial natin ay 1 second. So what's X initial? So substitute lang natin sila dito. So that will be 2 times 1 squared minus 10 times 1 minus 2. So X initial is negative 10. Tama ba? Negative 10 meters. And then T final is 4 seconds. So X final is equal to 2 times 4 squared minus 10 times 4 minus 2. So X final is equal to 2 times 4 squared minus 10 times 4 minus 2. Negative 10 meters. So therefore, the average is negative 10 minus 10 over 4 minus 1. So the answer is 0. Okay, tama ka, Michael. So it is 0. Parang bumalik siya sa dati, no? Parang gumanyan siya, tapos bigla siya bumalik. Okay? Very good. Okay, how about letter C? What is the instantaneous velocity at 3 is equal to at t is equal to 3 seconds. Okay, so remember, v is equal to dx over dt. Ayan. Can you tell me what is the derivative of our equation? Okay, so what is the derivative? Or the derivative of that is ilan? Ang derivative niya? Okay, it's 4. Okay, 4t minus 10. Okay, 4t minus 10. So therefore, the equation of our velocity is 4t minus 10. And then we'll just apply yung time na 3 seconds. So therefore, v is 4 times 3 minus 10. So therefore, v is 2 meters per second. Ayan. At 3 seconds, the velocity is yan. The velocity is at 2 meters per second. Okay, any question? Any question on this example on instantaneous and average velocity? Wala yung question? Okay, so wala. Okay, so let's proceed to our next lesson. So we're done with velocity and speed. So this time, we'll be discussing acceleration. Ayan. Okay? Acceleration. So acceleration na tayo. So we're done with position, we're done with displacement and distance, and we're done with the speed and velocity. Now let's go to acceleration. Okay. So in general, ano ba ang ibig sabihin ng acceleration? Ang ibig sabihin ng acceleration ay it is the rate of change of velocity. Siyempre, with respect to time. With respect to time. Ayan. So this is the rate of change of velocity with respect to time. So that is the general definition of acceleration. So what does this mean? Basta't nagbago ang velocity ng isang object or particle habang nagmo-move siya, nagbago yung velocity niya, meron siyang acceleration. Okay? So, meron siyang acceleration. Basta't merong change sa kanyang velocity, meron siyang acceleration. Okay? Anong unit ng acceleration? Kasi by definition, yan, ang acceleration dapat meron daw change in velocity with respect to time. So parang yung acceleration, there should be a change in velocity with respect to time. Yeah, change in velocity with respect to time. So therefore, ang velocity ay in SI, it's in meter per second. At in time natin is second, kaya siya naging meters per second squared. So sa English naman, that's foot per second all over second, kaya siya naging foot per second squared. So yeah. So by definition, acceleration is the rate of change of velocity, of course, with respect to time. So dapat nagkaroon ng change sa kanyang velocity. Okay, so meron tatlong klase ng way or paraan para masabi natin na yung object ay meron siyang acceleration. So ano yung tatlong yon? So meron three ways to say. Okay, class, these are very important kasi related sila sa next lesson natin. Okay, three ways to say na meron siyang acceleration. So yung una ay nag-speed up siya. Paano ba yung speed up? So halimbawa, naglalakad siya ng let's say, ang initial velocity niya ay 1 meter per second. Tapos bigla siyang tumakbo na yung final velocity niya naging let's say 4 meters per second. May nagbago ba sa kanyang velocity? Yes, from mabagal na 1 meter per second, tapos bumilis siya ng 4 meter per second. Kaya siya speed up. So speed up is one of the ways para sabihin natin meron siyang acceleration from a lower or slower velocity. So, nagbago yung kanyang magnitude, tumaas, kaya siya nag-speed up. Okay? And number two, what do you think is the second one? It's related to the first. Now, what do you think? Na related sa first. Siyempre, yung kanyang kabaliktaran. So, yung kabaliktaran niya ay, kung nag-speed up siya, yung slow down din. Yan. Okay, pag nag-slow down siya, siyempre nagbago din yung kanyang magnitude. From, let's say, ang initial velocity niya ay 4 meters per second, tapos bigla siyang naging, let's say, 1 meter per second. So, meron bang change sa kanyang velocity? Yes, yung magnitude nagbago from a faster velocity. So, bumagal siya from 4 meters per second, naging 1 meter per second. Bumagal siya. Kaya nag-slow down siya. So, that means the change in the velocity caused the acceleration. Okay? And how about the third one? So what do you think is the third one? Itong third one is not very common. It's not common. But if you had your high school, kung nag-circular motion kayo, related siya dito sa second law ng Newton's second law. So one of the applications of Newton's laws of motion ay isang perfect example ng pangatlo. Kasi hindi siya masyadong napapansin. Okay? Ano yung pangatlo? Yung change in direction. Ayan. Speed up, slow down, and then change in direction. Bakit nagkakaroon ng acceleration kung nagbago lang yung direction? Okay? Tandaan ninyo, ang velocity kasi ay vector siya, di ba? Ang velocity kasi ay vector siya. Pag vector siya, so ibig sabihin, meron siyang magnitude at saka direction. So, kung nagbago yung magnitude niya, ibig sabihin, nagbago yung kanyang velocity. Kasi nga, nagbago yung magnitude. At yung unang dalawa, yung speed up at saka slow down, silang dalawa ay nagpe-pertain doon sa change in the magnitude. Okay, so limbawa dito sa speed up, syempre tumaas yung magnitude niya, nagbago, tumaas. Yun naman slow down, bumagal yung kanyang magnitude. Kaya nagkaroon siya ng acceleration. Okay, so yung magnitude is just one part of the velocity, which is a vector. It also has a direction. Okay, so even if the magnitude remains the same, if the direction changes, the velocity also changes. And that means if there's a change in the velocity, there will be acceleration. Kasi by definition, if there's a change in the velocity, there is acceleration. Okay, so even if the magnitude remains the same, but the direction of the velocity also changes, there will also be a change in the velocity. And that change will cause the acceleration. Kasi by definition, any change in the velocity, if there's a change in the velocity, there is acceleration. So yun yung definition ng acceleration. May question ba kayo? Okay, so siguro ganito yon. Ang example ng direction, halimbawa nagda-drive kayo ng paganyan. So let's say that's 32, 20 na lang. 20 meters per second. Tapos bigla kayong lumiko. Ayan. But you're still running at 30 meters per second, pero nagbago yung inyong velocity. So is there a change in the direction? Yes. And there's a change. If there's a change in direction, is there a change in velocity? Yes. So that means there is acceleration. Okay, yung sa circular motion naman, so halimbawa, di ba may papaikot ka, sobrang tali siya dito, tapos nakatali yung, let's say, yung bola, tapos pinapaikot mo, at pinapaikot mo at a constant, parang mga Ferris wheel, yung mga rides, di ba, they are running at a constant speed. Class, I'm saying speed, not velocity. They are running at a constant speed. At a constant speed. Okay, so halimbawa, nag-run sila at a constant speed. Okay, but acceleration is not about speed, it's about velocity. Constant speed. And then, ayan, paano siya nagkakaroon ng acceleration due to the changes in the velocity? Kasi, pag circular siyang ganyan or meron siyang path na curve, ang velocity natin is laging tangent dun the path taken. So that means, kung nandito siya, ang direction ng velocity ng object, nung nandito siya sa point na to, is ganito. So nandito yung kanyang direction. Pag nandito naman, ito yung kanyang direction. It's always tangent to the path taken. Pag nandito naman siya, ito yung magiging direction ng velocity. Ayan. Okay? Kaya, meron pa rin siyang acceleration kasi kahit hindi nagbabago yung magnitude or yung speed, nagbabago pa rin yung direction. So there's a change in the velocity still because the velocity's direction is changing. Okay? At ang tawag sa acceleration, particularly sa example na to, ay yung centripetal acceleration. If you could remember sa physics sa high school, yung circular motion, centripetal force at saka yung centripetal acceleration. Sometimes they also, we also study yung centrifugal force, but that thing, hindi natin yung pag-aaralan. More of yung centripetal lang. Centripetal is something moving towards the center. Okay, but ayan, so ito, kahit hindi nagbabago yung speed niya, which is the magnitude of the velocity, it still has direction, it still has acceleration because the direction of the velocity is changing. Okay, any question? Ayan, I'm just trying to discuss what acceleration is. Okay, ang sabi pa nila, ang acceleration is something you feel. If you cannot feel any change in the, if you cannot feel something, if let's say you are in motion, whether naglalakad ka, nagbabike ka, or nakasakay ka ng sasakyan or jeep, aeroplano or what, if you cannot feel any change in your motion, cannot feel something, something is changing, that means there is no acceleration. Kasi ang sinasabi nila, acceleration is something you feel. So example, naglalakad ka tapos bigla kang tumakbo, meron bang pagbabago dun sa nararamdaman mo, dun sa dalawang type ng motion na yon, nung naglalakad ka tsaka nung bigla kang tumakbo. So di ba parang feeling mo, hinahabol mo yung hinanga mo or napapagod ka kasi, ayun, yun yung isang sign na meron kang acceleration kasi you felt something. Okay, gano'n din naman sa pag-slow down. So, halimbawa, nagda-drive kayo ng mabilis, let's say nasa jeep kayo, and then biglang nag-sudden stop yung jeep. O, di ba, sa inertia, di ba, parang may feeling na yung mga pasahero pupunta sa harap o mapapaano ka sa harap. Ngayon, so it's something you can feel. So, that means there's acceleration from a very fast motion to a sudden stop. So, syempre, mararamdaman mo talaga yon. Yun sa change in direction. So, ito, di ba, yung parang mabilis yung takbo mo, tapos bigla kang kumaliwa, di ba may tendency na parang napapapunta ka dito sa portion na to. So, since you felt it, that means there is acceleration. So, yun yung sinasabi niyang acceleration. Okay. May question ba about acceleration? I will ask you something. I always ask this thing to all of my physics students because may papapol ako and then wag mo na kayong sasagot kasi hintayin niyo muna yung tanong ko bago kayo sasagot. Ayan. So, meron tayong 4 na choices. Okay. So, ito na yung tanong. Halimbawa, nakasakay ka sa passenger seat ng isang kotse and then, nagda-drive kayo ng mabilis sa expressway, as in mabilis, pero constant yung velocity ninyo. Okay. Constant ang velocity at nagda-drive kayo ng mabilis doon sa expressway. Kaya lang, nauhaw ka, gusto mong uminom, pero ayaw mong uminom sa bote. So, ang gusto mong gawin is ilalagay mo yung tubig sa baso. Ayan. Sabihin na natin, tinaas mo siya ng 1 foot para ibuhos mo yung tubig doon sa baso. Ang tanong, ayan, ang 4 na yan. Nagda-drive kayo ng mabilis sa kotse and then ibubuhos mo yung tubig sa baso na constant yung velocity ninyo. Anong mangyayari sa tubig? Mabubuhos mo ba ng maayos? Matatapon ba sa iyo? Matatapon ba sa harap mo? O depende? Siyempre, yung mga sasagot ng kailangan, didepensa sila. Okay, so probably I can check the attendance. Okay, so yung 7 ay hindi pa sumasagot. Nasaan kaya sila? Ayan, yung 4, 6 na lang. Okay, sabi ng nakakarami, ang sagot nila ay mabubuhos ng maayos. 3 ang nagsabi ng matatapon sa kanila at 1 ang nagsabing matatapon sa harap at 3 ang nagsabi ng depende. Okay, actually curious ako dun sa depende. Mamaya sasabihin yung sagot. Sige. Mga sumagot ng depende, bakit nyo nasabing depende? Kailangan mag-explain. Okay, sa tingin nyo, bakit depende? Ayan, sumagot na si... Ayan, nag-explain si Charles. Baka may sira yung daan. Si Ralph naman, di po nabanggit kung maayos po yun. Sinabi ko naman, it's expressway. At tapos, may hint pa rin kayo doon. Constant yung velocity. Constant yung velocity. So, ibig yung sabihin, pag sira yung, hindi maayos yung daan, anong mangyayari? Matatapon. Kung maayos yung daan, walang humps. Wala naman humps sa expressway. So anyway, kung kung maayos yung daan, okay, malalagay ng maayos yung tubig. Kung with constant. Okay, sige. Okay, point taken, Charles and Ralph. Okay, how about yung sumagot ng iba? So, gusto nyo bang mag-explain nung kasi yung depende kasi madaming condition din naman yun eh. Yun yung point nila. So, how about the others? Yung mga sumagot ng mabubuhos ng maayos, matatapon sa iyo at matatapon sa harap. Okay. So, ito yung sandali, si Angelo sasagot. Okay. May equilibrium. Okay, advance tayo ng konti. May equilibrium. Okay, so tama, may equilibrium dahil, so explain ko muna bakit may equilibrium. Paano ko ba sisimulan? Pag ang acceleration kasi ay 0, kung natatandin nyo ang Newton's second law, yung net force is equal to ma. Pag ang velocity ay constant, so that means yung acceleration ay constant. So kung acceleration ay constant, so that means yung net force or all the forces acting on the object are canceling out. So nagka-cancel sila. So yung naging net force ay nagiging 0. Okay, so isang condition ng equilibrium ay yung net force ay 0. Kaya nasabi ni Angelo na may equilibrium. Kasi dahil pag merong constant velocity, ang acceleration ay zero. Eh kung ang acceleration ay zero, yung net force or all the forces acting on this mass will also become zero. Okay, that's a condition of an equilibrium. Ayan. Okay, so thank you for your responses. Okay, so tama kayo tatlo. Depende kasi gusto ko lang baka meron kayong maisip na wala doon sa condition na sinabi ko. So isa pa siguro, in-answer nila to sa akin, sir, baka depende kung bukas yung bintana, sabi mo. Okay, so that's another one. Kasi kung bukas yung bintana at may hanging papasok doon sa loob, syempre, definitely, matatapon sa'yo, di ba? Pero kung susundin lang natin, mag-stick tayo directly doon sa sinabi ko, constant velocity, it's a car, everything is closed, and everything is moving at the same time, so tama yung sagot na mabubuhos ng maayos. Okay? Kasi it has something to do also with relativity na lahat ng bagay doon sa loob ng kotse, kung walang hangin na papasok, is nagmo-move sila at the same time. Even though nagmo-move na sa loob ng kotse, nagmo-move sila sabay-sabay. Okay, parang kung papansinin nyo din, di ba kahit mabilis kayo, di ba yung buhok ng mga mahaba yung buhok, hindi naman gumagalaw. O kaya yung mga, di ba meron silang mga accessory dun sa salamin na hindi rin naman gumagalaw. Kasi lahat kung may constant velocity or walang acceleration. Kung walang acceleration, that means maganda, smoothly naman yung magiging motion ng mga lahat ng bagay dun sa loob ng kotse. So, isa rin dahilan yan. Bakit kahit yung mga bullet train, class, di ba? Kung nanonood kayo ng mga movie or nakasakay na kayo ng bullet train na mabilis, di ba meron mga cafeteria doon? So, kung hindi po pwedeng ibuhos mo yon ng maayos or uminom ka ng maayos habang naglalakad yung sinasakyan mo, so hindi ka pwedeng mag-cafeteria sa mga ganon. Or dun sa aeroplano, di ba mabilis yung aeroplano? Pero bakit yung mga steward at saka stewardess, di ba nakakapagbigay pa sila ng tubig at pagkain? Okay, it's because of acceleration. If the acceleration is zero or the velocity is constant, that means you can do anything kahit mabilis pa gumagana yung bagay na yon or yung motion mo ay nagiging constant. Okay, kahit tatalong ka pa sa aeroplano, hindi ka na mapupunta dun sa likod. Kung saan ka tumalon, dun ka pa rin naman mahuhulog. Or kahit sa bus na mabilis, pero dahil wala namang acceleration, kaya mong gawin yon. Pero kung merong acceleration, let's say biglang pumreno, biglang bumilis, biglang lumiko, ibang usapan na yon. So hindi mo na yun kayang gawin. Or magkakaroon na ng problema or something like that. Okay? Nakuha ba yung point? Okay, so that is acceleration. Okay. So ang susunod nating lesson is about average acceleration and instantaneous acceleration. So I think we will just continue that next meeting. And then patapos na tayo dun sa introduction natin ng kinematics. Okay, any question? Hi class, so that's it for tonight. So see you next meeting.